Okay, so it's 2 o'clock, so I think we'll get started, and I'm sure some other listeners will be trickling in. My name is Nicole Van Wert-Quincy, and I'm from Transcat, and I'll be your moderator this afternoon. Our webinar topic today is improving safety in the industrial workplace with infrared technology. The topic is being presented by Elliot Shemtov from FLIR. Elliot has been in the test and measurement industry for 13 years. He is a level 1 certified thermographer, and he works as FLIR's Northeast sales manager. He's been with FLIR for 4 years. We expect today's presentation to last roughly 30 to 40 minutes, and then we'll answer any questions that have been submitted during the presentation. During any time during the presentation, you can submit questions through the question box to the right in your webinar controls. I also want to mention that this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Elliot.
Thank you very much, Nicole, and thank you everybody for being on the webinar. I really appreciate you taking time out of your busy day to attend. So my name is Elliot Shemtov, as Nicole said. I am the sales manager in the Northeast for FLIR Thermal Imaging Systems, and it's a real pleasure to be here today for Transcat doing this. We're going to talk about improving safety in the industrial workplace with infrared technology. So when you look inside your tool bag, you also want, let me back up here. Looking inside your tool bag is on the agenda as number 1. Introduction to infrared technology 2. We're going to then be looking at 3, thermal imaging cameras, the tool you need, application overview, safer and faster troubleshooting with FLIR, choosing the right camera for the right job, and what is infrared guided measurement. And I want you to remember that term or that acronym, IGM, because that's going to be really important. We're going to segue at the very end on what IGM truly is and where the industry is kind of going with IGM. So you look inside your tool bag and you see lots of things, pliers, screwdrivers, the tools that are needed for the job. These are all things we must have to get the job done. But what's missing? What's the one thing that we need that's going to tell us something that we don't already have? Okay, information is power. The tools are used to fix the problem. So we need as much data as we can to A, cut down the time that we are used for diagnosis and for fixing, and B, be more cost effective. So we're talking about a thermal imager. What is a thermal imager? It's a tool that actually allows you to see temperature differential. So in the world of electric, it's the hot spots. In the world of HVAC, it could be the cold spots. It's basically surface temperature change. So why do we want to see heat? We're looking for anomalies. So if you look at a motor and you see the bearings actually heating up, you're able to tell just by looking at the image in a snap second if those bearings are an issue. And then you're able to look at your temperature on the screen as well at your specific target or pixel point and find out how hot that target potentially is, or i.e. how bad is the problem. And if we're looking at the left-hand side, we could see that on those 3 plugs, on those 3 phases, I'm not sure if that's phase A or phase C, but we could see the top phase definitely is much hotter than the other 2 phases, which indicates a problem. Without a thermal imager, we wouldn't know if that was an issue. What about absence of heat? So is not having heat the only thing thermal imagers do? And that's not true. So the absence of heat is still temperature change, but it may be cold spots. So what we see here is some missing insulation up on the top left. The bottom, we're looking at leaky windows, and on the top right, we're looking at an AC vent, some ductwork that didn't hold up where it was taped, where the wall meets. And now we have some cool air on a nice hot day, some cool air from the AC kind of bleeding through the wall. Once again, have we all sat in rooms and felt the draft but the windows were closed? I can tell you this, I've probably felt that many times in my life, but without a thermal imager, almost impossible to diagnose. So we think about the technology and where it was in 1965. We created infrared technology in 1965. FLIR is the original thermal imaging company. FLIR standing for forward-looking infrared. I mean, heck, you had a tremendous tool back in the 60s and 70s with a big container that you had to pour a certain type of liquid gas into, and then the detector shot something, and you had this black and white image. By the way, that ugly black and white image that gave you a hotspot was probably $100 and something thousand. You look at the second image I just brought up, that's what the technology looked like in the late 70s going in through the 80s. That was actually a very small device. And then in the 90s and early 2000s, the device got even smaller, more compact, less costly, and now today we have cameras that are actually half the size, if not a fraction of the size, that that gentleman there in the mid-2000s is holding. And that's what we have today. We have cutting-edge technology unlike any other company in the market. And this is the one tool, and you'll see as I go through the presentation, this is the one tool that's going to tell you the things that you need to find out when you're on the job, whether it's in a building, whether it's in a community, whether it's a residential, commercial, industrial. It really is an incredible tool that helps pay itself back quickly. So I know everybody that goes on these calls, they want to find out the latest and the greatest, but let's bring it down to a macro, or I should say a micro level. What's in it for me? What is this tool going to do for me, and how is it going to make my facility or my bottom line tighter and better? So how do we get these cameras so small? FLIR is always working hard with one of the best R&D departments in the world, and we've been able to take that core detector, which you saw the first picture before. I'll kind of go back again right here, all the way to the far left. The core detector is probably about the size of my leg. And this is what the technology's been brought to over the last 2 to 3 years. That's called a lepton detector. That right there is an entire apparatus that runs a camera. That's got optics in it, that's got the core, and all the electronics to run the camera. So very, very incredible. So FLIR also has the most comprehensive suite of cameras. We have the EX series, which starts at $995 and goes to about $4,000. Multiple resolutions, and we'll get into resolution in a little bit as well. Then we have a mid-tier camera called the EXX, starts at about $3,750 and goes up to about $8,000. Then the T4 series, that's our Pro Series camera. Now you think Pro Series camera, probably very expensive. Pro Series cameras, again, we're always thinking along the lines of what's in it for me. Pro Series cameras are usually used for industrial, to commercial, to heavy industrial, light industrial technology, including residential as well. These cameras do a wonderful job of seeing farther away distances and targets and giving you very good clarity. And then there's the T6 series. The T6 series is our most upper tier series, primarily used on heavy industrial and the refining business, universities, and so on, where basically targets are very expensive and failures could mean tens of thousands of dollars in loss. And then we just released the T1020. The T1020 is what I'd like to call our super camera. That's a camera that has the highest resolution on the market and the best optics. Who would use a T1020? A T1020 would be used again by a refinery where you're looking several hundred feet. You know, you look at the different models and the different price ranges and you may say, why are there different prices? Why are there different, ranges in cost? So let me be clear, resolution, and we'll get into this in a little bit, resolution is really the name of the game in this business. The more resolution you have in a camera, generally the more sensitive it is and the more accurate it is, it gives you farther distance, the better the resolution, to meet your target and get a proper indication and diagnosis of what the issue may be. So you can imagine cameras that are 80 by 60 are only going to give you good accurate information and clarity from a couple feet away, whereas when you're looking down at the bottom of the screen, that T1020, or it's dubbed the 1K camera, that camera basically can see several hundred feet away and give you a pretty accurate temperature reading. Now we've also released, you'll see on the left-hand side of the screen, we've taken that lepton core that we showed you before, that real tiny little camera core, and we're able to insert it into micro tools. So now we have very small little thermal imagers like the TG165. These cameras are made for spot inspection. These are cameras that are more made for reactive type maintenance. So if you have an issue on a motor and you need to pop it out real quick, this is something that replaces those age-old $100 or $200 little spot guns that only give you the temperature. These cameras now have the ability to take a picture and save it, bring it back up on the screen, change the emissivity, change the color palette, download an image to a computer in JPEG format, and we have a C2 camera, which is below that. That's a full-size camera in something that weighs about 1/3 of a pound and the size of a little bit bigger than a pack of cigarettes, probably thinner. And then we go right down to the FLIR 1, a camera core on the bottom left-hand part of the screen that plugs into any iPhone or Android device, thus turning your cell phone into a pretty powerful thermal imager for only $250. So that lepton core not only has made the technology smaller, but it's also made it more cost-effective and affordable. And there's the FLIR 1 here. So kind of backing up what I spoke about before, the pros are going to be the cost is going to be low, instant image sharing, you can take a picture and boom, you can send it right off in an email or a text message to someone, and it's very tiny. The cons, well, the cons are it's a consumer electronic device, right? So the durability, it's not made with a drop rating like our other cameras. The battery, it has its own battery, and you can't put anything big in something that's small. And it's not going to be super accurate because you don't have the high resolution. It's 160 by 120. So on the scale of resolution, it's probably on the lower to moderate end. So you really, it's good for looking at targets about, I'd say anywhere from 3 to 5 or 3 to 6 feet away. But a great device for $250. We always have to think about return on investment. What is this device going to yield us? Is it going to find enough things quickly to pay for itself? And, you know, back in the day when I worked for a distributor, I was a big specialist in lighting. And I still know a lot about lighting and LED and so on. I know that when you're doing an incandescent lighting project, a good project time for ROI is about 18 months. Thermal imagers, 3 weeks. So it sounds pretty incredible, but think about it. If you look at a bunch of windows in your house and you find out that they're leaking, and your home heating and air conditioning bills are jacked up by $30, $40 a month, you do the math. That FLIR 1, just by putting a little bit of silicone around your windows, may have paid for itself right off the bat. And now you have it for the next 5 or 10 years, finding all kinds of issues, whether it be in your automobile or your front door or your heating unit or your air conditioning condenser or your panel in your house. So when you really think about the power of that tiny little unit, $250 may have saved you a couple $1,000s. Now we look at the TG165. I kind of explained a lot about it before. I have the propensity to do that, so I apologize up front. I get excited, so I like to talk about the products before they start popping up. I'm not going to go too long into this, but this is a drop-rated product. This is the next step up from the FLIR 1. So if you're looking for something more durable, that's industrial grade, that has the ability to get knocked around, thrown around in a toolbox, this is the camera right here. It's got a little less resolution, but it's got a little more functionality for a standalone item, and it's got a really long battery life that lasts about 5 to 10 hours. It's got a 10-year warranty on the core as well, and that starts at $349, so also very inexpensive for what it does. And then we talked about the C2. This is a pocket portable. The images are fully radiometric, meaning you can do reports on these. You can download the images and put them into our reporting software. It's even enhanced with what we have, what's called MSX. MSX stands for Multispectral Dynamic Imaging, and that's a real fancy acronym that means probably nothing to you, but what does it do? It takes the visual image and it overlays it on top of the infrared image. So if you look at that image on the camera screen, you can clearly see a lot of finite detail that regular thermal imagers wouldn't pick up. This camera will pick it up, thus enhancing the resolution and the image, giving you far superior image quality than any of our competitors in the field, and it's a touchscreen as well. So think about it. This camera, which is full functioning and does reports, so if you're doing PMs or you have a PDM program, this is a $699 camera. So think about it. Thermal imagers went from over $100,000 for full reporting tools 20 years ago to $699. Pretty incredible. Our EX series platform, I kind of also explained a little bit about. It's our first entry level into a full-size unit. It's lightweight. It also does reports. It has fixed focus, so you don't have to hit a focus button or auto or manual focus it. And there's 4 models with 4 different resolutions. Each one subsequently has more resolution than the previous one, thus giving it more range, accuracy, and sensitivity. And then the EXX platform. We have an E40, 50, and 60. This has enhanced temperature range, so this camera can shoot as high as 1200 degrees, whereas the one before it, the EX, only shoots up to 485. So this guy right here shoots up to 1202, has a larger screen. You can change optics on it. There's an auto zoom, digital zoom, advanced analysis modes. You can link this through Wi-Fi peer-to-peer to your tablet or your cell phone. And it has a whole host of other features and functions that pretty much even rival our Pro Series camera. And for a great midline industrial grade camera, you can't beat the price of $37.50. It's a wonderful camera. It's actually one of our flagship series. And then the Pro Series. The Pro Series goes anywhere from 1202 to 3600 degrees in temperature, the best image quality in the market, great lens capabilities. You can change optics on these, also connectivity to a laptop, or you can run a live stream right to any portable device. Simplified on-screen reporting. You can actually do reports right on the unit itself. This is our Pro Series camera. 85% of what you're buying is resolution, which again dictates sensitivity, accuracy. It's indicative of clarity and distance to target, basically. So when you look at a camera and you see the cost of a camera, our cameras range from $250 to $42,000. You can almost guarantee that the cameras that go up the scale in cost are going to go up the scale in resolution. But again, usually your targets that you need the larger resolution for, the return on investment's higher. We're talking about switch gear, switches, all kinds of breakers that are very expensive. And there's a little differences here between the T4 series and the T6 series. So you can see the resolutions are dramatically different. The T4 series is all 320 by 240, which I get the question quite a bit, and I just want to go through this for 2 seconds. People always say to me, Elliot, where does good resolution start? Where does industrial grade resolution start? I work in a facility, it's 200,000 square feet. I want to get good image quality. I want to keep, my budget is X and Y. Where does that start? And I tell everybody, really good industrial grade resolution starts right here at 320 by 240. That T4 series is a wonderful series. It's well under $10,000, and really the accuracy and the imagery is phenomenal. Again, for situations where you need the farther distance and you need the enhanced temperature, you want a larger screen, and you want to add larger optics, the T6 series is the way to go. And again, we're talking return on investment. We're talking about using the camera, and if I use it 3 to 5 times, will I pay for it? That's my favorite. That's my favorite question. Real quick, I'll use a quick scenario. I had a customer over in New York City at a university. I don't want to mention which university, but they did say that they had some switchgear that they were concerned about. He got a quote. He kind of thought about it, went back and forth. He was looking at a T420, which was an $8,700 camera. He didn't buy the camera. I guess they got crunched on their budget. I didn't hear from him for 4.5 months. I got a call at 10:30 at night, which is odd. My customers don't call me at 10:30 at night. Usually if someone's calling at 10:30, it's a misdial or a prank call. So I get the phone call. I need you to come in immediately tomorrow. And I was like, why? Well, we had a blowout. One of the pieces of our switchgear melted down. Fire department came. We had no idea the cabinet door was closed. We never did a PDM on it because we didn't have a camera. It must have exceeded 800 to 1,000 degrees, and it literally blew up. $25,000 piece of switchgear, and then the collateral damage around it. Total bill, $90,000. Could have been avoided if he had bought the camera. Not just my camera, could have been any thermal imager. They would have saw that. So one usage would have saved him the grief and a very, very bad night. And then the 1020. The 1020, we have to put that in a category of its own, even though it's a T-series. This camera really has amazing, amazing imagery. You can see the image on the screen right now. That's an image from about 40 feet away, and really it gives you an amazing infrared image and an amazing image of visual mixed in with it. So just a great, great camera overall. I know I'm using a lot of big adjectives and I'm not putting a lot of substance behind it, but again, the proof is in the image. When you get those great images and you get that great accuracy from a far distance, that's what you're paying for in a thermal imager. Applications. What are we using it for? What can a thermal imager be used for? We talked about windows and electrical and motors, but there's a whole bunch of things we could use it for. So the first thing people think of with thermal imaging is the electric room. You know, this is fantastic for the electric room. I could see, and that's the low-hanging fruit, right? Electrical gets hot. Dealing with electrical is kind of like a doctor dealing with human beings. A human being gets hot, that means we got a problem. We're sick. Okay, we're 105 degrees. We go to ICU at the emergency room. Electrical gets hot. We know we have a problem. We start checking it. Most likely it's bad connections, but it could be load as well, or a combination. But there's much more to just electrical with thermal imaging. And you know, you're probably thinking in your head, okay, yeah, you know, temperature change. Lots of things change temperature, and that's a good indicator of a problem. So now when you take a look here, motors, bearings, tanks, belts, machinery, panel boards, energy audits. It goes on and on. Roof inspections. Roof inspections is another huge usage for these cameras, and I think we'll get into that also later on. So we talked about electrical. We're also looking at electrical not just to diagnose the problem, but think about it. If you were to go and take a load reading, just a various, you know, load reading, we wanted to just see what the load was on this, or maybe the machine was malfunctioning. First thing we're going to do is put a clamp on, or put a flex clamp around that. Well, I got news for you. If there's a bad connection that's causing that problem to heat up, chances are if you go agitate that cable or that wire connected to the phase, you may cause a pretty bad arc flash, or it just may arc as you open up the cabinet. So you want to have the right PPE on, but you want to keep a nice distance away as well. And a thermal imager will allow you to be within a safe distance, and so in most cases within NFPA 70E compliance. And this is all pretty self-explanatory. Mechanical. So we talked about bearings being misaligned and hot. Lubrication issues. Pretty simple, right? If something's not lubed up properly, you have too much friction. Friction causes heat. Heat causes distress. We got issues. So there you see two chain-driven devices. Chain-driven device on the right, fine. On the left, not so fine. Tank levels, you'd be shocked. Fluid tends to hold a different temperature depending on what the fluid is, but most fluids, everything from water to petrol to anything, cleaning fluids, you name it, it usually holds a different temperature than ambient. So generally you have ambient, you have the temperature of the tank, and then you have the actual temperature of the fluid. You can check out tank levels. So here's a nice sunny day. We're looking at the tank. The sun is actually heating up the contents of the fluid, which works in our favor. And we're able to see that that tank is just about, I'd say probably about 5/8 full, you know, 6/9, whatever, 6/10, whatever you want to call it. I'm bad with my fractions, but it's pretty full. And we can see exactly where the tank level is. So if our gauges aren't working, or if we need a quick snapshot, think about the time saved before we had to climb up that tank and look at the actual level of fluid in the tank, or look in the tank. Fluid distribution, leaky valves. I mean, that's pretty obvious, the issue right there, just by taking a peek with a thermal imager. Steam traps. Steam traps are one of my favorite. Simply by looking at a steam trap, you're able to see if there's a clog or an issue, or if it's functioning at all. I know most hospitals that I've done inspections in, being a level 1 certified thermographist, I've looked at 1,000 steam traps, and I've done them all in one day. If you're using a spot gun, which is what most people use, well, a spot gun, you're going to be there probably for about a week, because you have to look at each trap, go over every part of it, and make sure the temperature is consistent on all portions of the trap. And then building maintenance. We talked about air sealing. You can see where there's some recessed lighting, there's some bleeding coming through that, and so on. Attic door, electrical outlet. This is all bad insulation. So finding bad insulation, or missing insulation, or spotty insulation, a lot of times you do blown insulation, which is phenomenal, but sometimes it doesn't always get blown in perfectly. You're able to spot the issues. I guarantee if you go through any home, you can find these problems almost in every single home. The question is, how severe is the issue? That's where temperature comes in. Building maintenance. So the image on the left is really interesting too. You'll see that there was actually a bathroom on that top level, and the shower was leaking, and the water from the shower went between the sheetrock and the flashing and got behind the siding. And you can see where that water leak and corrosion will end up building up, causing big time issues that will lead to mold and all kinds of other problems. So thermal imager detects that in seconds. Various other issues as well. Leaky roof that caused a leaky ceiling in the top right. Energy efficiency. We talked about insulation. So there's the visual image on the left. On the right, you can clearly see where there's a whole strip between two studs that never got any insulation at all. Talk about chinsing out, right? $10 in insulation, they missed a whole section. So what's a thermal imager good for? Well, you're kind of looking at all these pictures now. I think that's Mr. Ed in the middle. Good for just about anything. And the irony is, I didn't put the picture of the horse in there to call him Mr. Ed and get a little bit of a chuckle out of you all. Equine usage is huge. You can actually check equine, the horse's legs, to see if there's issues with blood flow or a broken limb. So you'd be shocked, and they usually buy T6 series, which are the higher end series, because they want the finest, best imagery. Generally, those horses are going to be race horses or horses used for high dollar value. So what did we learn today? We learned we can troubleshoot much easier with a thermal imager, but look before you act. Thing is, we can't see the problem. FLIR's thermal imagers can see the problem. And here you can see an issue, a nice delta of about 30-something degrees on the left. A bad phase that will eventually lead to a very bad problem. Safety first, right? Just not about diagnostics. It's about being safe. At the end of the day, it's fantastic to find the problem. But like any police officer would say when you ask him about his job, what's rule number one? Get home at the end of the day for dinner safely. Which model's right for me? Application, temperature range, reporting, field analysis, size of target, and distance to target. I should have put that one on top. That's number one. Indoor or outdoor? That's the question. Well, I will tell you this. You have me as a resource. You have Transcat as a resource. Transcat has a great infrared department. They are tops in the game. You have myself out there as well. So if you ever get stuck, you know who to talk to. But it basically goes from troubleshooting to performance to professional usage. As you start to increase cost, you increase resolution and features. So you're going to get more as you start to go up in the series. It all depends on what you need, though. Key points to remember. With FLIR, the big difference between our competitors is FLIR uses a universal type of image. When we shoot with a FLIR camera, all FLIR cameras, we are shooting in JPEG. All of our competitors shoot in locked images. You need their proprietary software to view them in the raw form. With FLIR, you feed it right into your PC with no software. You can view a raw image. You can send it, receive it. If you want to edit it, you have to put it into the FLIR software. By the way, FLIR used to sell the software called FLIR Tools. Back then it was FLIR Quick Reports or FLIR Reporter. That's a $2,500 package. Today, the FLIR software is free. No matter what camera you buy, whether it's a C2 for $699 or a $42,000 T1020, the software comes with it and it's free, no charge. The image enhancement, MSX, only with FLIR. Connectivity. FLIR has a proprietary Wi-Fi connectivity from our cameras to our handheld devices, and warranty. FLIR is the only company in the industry that gives you a 10-year warranty on the detector, and I might add also a 5-year warranty on all the lithium-ion removable batteries. So if it has a battery that pops out to recharge, you get 5 years. And 4 years from now, if your battery doesn't hold a charge, FLIR will give you a brand new battery with a fresh 5-year warranty. We're the only ones in the industry that'll stand behind our equipment in that matter. So let's go back to that lepton core, that little tiny core. This looks big right here, right? That core is about the size of look at your pinky nail right now. Take a quick peek at it. Your pinky nail is tiny, and I got moderate sized hands, so it's still tiny. That's how big that core is. And that core still has the ability to add MSX, which you can see the difference. We talked about that earlier. That is the image enhancement. That's where we take the visual image and overlay it on top of the thermal image. And you can see the difference between a standard infrared image. All of our competitors look like the left. We look like the right. Big difference. We talked about JPEG, Wi-Fi and Bluetooth. I'm going to skip through this because we kind of spoke about this. Like I said, I like to jump out ahead of the bunch. This way we get right down to the meat of the presentation and skip through all the other stuff. And now FLIR meters. So FLIR was known, and still is known, as the #1 infrared camera in the industry. We got about 88% of the market. We are the Nike of infrared, the Yankees of infrared. And maybe the Yankees is a bad example. I guess the Cubs of infrared, if you're from Chicago, since they won the World Series. So we decided, because we have such a wonderful product, we want to follow that up with wonderful meters. We have the ability to take our meters and use them with our cameras. We can connect them through Bluetooth technology, this way getting enhanced reporting capability. All of our meters have limited lifetime warranties. Now, let's go back to this guy again, the lepton detector. Ever so small and so tiny. Do you see where I'm going with this now? We're talking about cameras. We're talking about lepton. We're talking about meters. How about meters with IGM? Infrared guided measurement, meaning how about a meter that before you clamp on or do some diagnosis, you're able to look at the problem using infrared built into the meter. That's where the industry is kind of moving right now. Meet the DM284. The DM284 has a large screen, a 3-meter drop rating. It's water resistant. It's got an OtterBox type shell around it. It's the size of your hand. It's basically a handhold unit. 2.5-inch big color screen, and very versatile with thermal imaging built into it. You'd say to yourself, a 160 by 120 thermal core built into one of the world's strongest military grade type meters that does everything from low Z to volts to amps to millivolts, everything. Okay, comes with batteries, comes with leads, professional leads that are silicone. You'd think probably a couple $1,000s. This retails at $749. We even have a trade-in program now. You trade in your old meter that's working or non-working. Even if it's a $20 crappy meter that broke on you, you get a $75 Amex gift card back until the end of the year. So really, really an amazing meter. I got 2 of these that I use for demos. I got to tell you, having this thing is wonderful because I turn it on, it takes 2 seconds, I hit the blue button, the infrared comes up, all my diagnosis stays on the screen. It's the new wave. So you can pinpoint problems quick and easy. You can see them on the screen. And you can troubleshoot like nothing else with this. This is what you get in the box. You get your leads, you get your batteries, you get your alligator clips, adapter, thermocouple, and you get the unit. So out of the box, ready to go. Pretty soon this month we're coming out with a rechargeable extended life battery for that. It does eat up batteries in infrared mode. In meter mode, the batteries last 16 hours. In infrared mode, they last 4 hours. But with the TA04 extended battery, you get 30 hours of life and it's rechargeable. So it's going to save you a heck of a lot of money in batteries, and it really is an excellent, excellent lithium-ion device. There's some other accessories on the bottom as well. And then you can get it as a kit as well. They have a flex clamp that has the ability to wrap around bus or MCM, and you can fit the whole thing in one nice little storage case. It's called a DM284 Flex Kit. It's a complete kit with the flex clamp, the case, everything you see for $899, only through Transcat. So a couple closing comments. Thermal imaging now has its place in that tool bag. So we saw a tool bag before that, a thermal imager, and I'm sure you could probably all agree to one degree or another that there is a place in that bag for a thermal imager, and there is going to be return on investment. What does it mean also? Not only are we going to diagnose the issue, which of course we always think money first, but when we take a deep breath and we slow down and we think about our lives, we're worth more than just a diagnosis, and being safe is extremely important. And that's it, everybody. So I wanted to say thank you very much. And there's also going to be some offers here, which Nicole is going to talk through for a couple secs, and then we're going to take some questions as well. So I'm going to hand it back over to Nicole, and again, thank you all very much, and I'm also looking forward to answering a couple questions if you have any.
Thank you, Elliot. So as he said, that concludes our presentation portion of the webinar, and now we're going to open it up to question and answers. And as a reminder, if you'd like to ask a question, you can send it through the question box in your webinar controls. The first question, someone asked about software, and I think you already covered that. She said, are you going to, or he or she, I didn't see the name, are you going to go to, show some examples of the reporting software? And you talked through that it is included. Is there anything else you want to say about that?
So the software is included. It can always be downloaded virtually off FLIR. You can go to FLIR.com/tools with an S, plural, T-O-O-L-S. Also, if you email me, I have some live web-based training on how to use FLIR tools. Plenty of screenshots, plenty of videos. It's about an hour and a half, 2 hours. It's a wonderful introduction on how to use FLIR tools. It's pretty much all drop and drag, so if you know how to use Windows and you're pretty decent with a PC, Again, very simple to figure out. A lot of it is just importing and exporting the images and then dropping them in and clicking on the different points.
Okay. The next one, do you rent infrared cameras? So yes, we do. We have a rental program here at Transcat. So if you're, you want to test one out before you buy one, or if you don't have the budget to buy one, we do rent several FLIR cameras. We have the T1020, which is the top of the line, T640, and then several of the E-series, E60, E8, and E40.
I want to just touch on that for a second. Just want to touch on that for a second. So anybody who's, everybody who's out there listening, if you happen to have a situation where you may only have one or two instances where you need a thermal imager, I mean, again, I think that they're priced to the point where everyone can afford one. But if you happen to have that really large issue, or you're doing a big PM and you need a T1020, call Nicole or call Transcat. You have the ability to rent it for a shorter period of time and pay a fraction of the cost, because there's a lot of people out there who really need the usage of a high-end thermal imager. They just don't have the budget for it, or they can't justify its purchase. So renting is an excellent way to achieve your goals and find the problems with your targets.
Great. Another question, how do I know how far a particular camera will shoot to give me an accurate target temperature?
That's a great question too. So we talked a little bit earlier about resolution being indicative of distance and accuracy. So thermal imaging at FLIR starts at 80 by 60. 80 by 60 is going to get you a couple of feet, 2-3 feet. Then you have 160 by 120. 160 by 120 is going to give you probably somewhere around 6 feet, 7 feet. Then you have that industrial grade resolution, 320 by 240. That really bumps you up now to about 12 to 14 feet. That's what you're going to need for that type of distance. And remember too, as you go up in resolution, you go up in clarity and sensitivity. And then when you start to move up to 480 by 360, you're going up about 18, 19 feet in distance. And then I always get the question, all right, what about the big boys, 640 by 480? How far can I shoot with those? Well, accurately, you could shoot 35 feet with those cameras. And then the T1020, which is I think 768 by 1020 in resolution, that's going to give you somewhere in the realm of probably about 50 to 100 feet of good clarity and accuracy. And then there's always optics. Some of these cameras from the EXX model and up, you can add optics to them. And what does that mean? That means you can add a telephoto lens and you can see twice as far and get the same accuracy.
Okay, next question. Can I use any infrared camera with the FLIR infrared windows?
You can, absolutely. Absolutely.
Okay. Next question. Can I take contact temperature readings with the DM284?
You can. There's a thermocouple that comes with it. You can use that for contact temperature readings. It's also a data logger as well. It has the ability to data log, I think it's 10,000 points. It's either 10 or 20,000 points of temperature of data. So the answer is yes and yes.
Okay. What is the difference between the TG165 and 167?
Great question. So the 165 has a 45-degree field of view. It has a wider field of view, so the image appears farther away. You need to stand a little bit closer. The TG167, same resolution, but remember, when you start changing those optics, you start playing with the distances. So now we have a smaller field of view, a 25-degree field of view. It's more narrow. When you narrow the field of view, you turn it into a telephoto lens. So the 167 will be able to see images from as far as 5 or 6 feet away, about 5 feet away actually. So you're able to go about twice the distance, and the image, or if you're at 2 or 3 feet, the image will look that much closer to you. So the 167 is a great device, and it's only $50 more. So if optics and looking at a cleaner image from farther away is important for a small micro handheld device, TG167 is a great toolbox tool to keep on your belt or in your toolbox.
Okay, we have another question that's got a little more detail in it. Which FLIR meter would capture an entire aircraft Pratt & Whitney radial 985 engine. The size is 6 by 6 feet, and they're looking for cold cylinders.
Great question. So let's think about this, right? If we want to get an entire aircraft in, and I'll give you a great example. I recently, about a year ago, I sold a camera to the U.S. Navy. They were shooting the wings of C-130 Hercules transports. So I think that's pretty comparable to your aircraft, right? Now, we were shooting the wings in the wintertime to make sure the elements were working properly to de-ice the wings. So we had to get the whole wingspan and basically the fuselage as well. They wanted to make sure it was also well insulated. These planes fly in every type of condition all over the world. I know that because I have McGuire Air Force Base by my house, and I see them flying just about, it looks like 10 feet over my house every day. I can pretty much see them visually. I actually shot that from about 50 feet away with a T660. So a higher resolution camera is going to be needed because you're going to need to stand farther back to get the entire aircraft in the field of view. So there's another option too. You can stand closer. We do have an upgrade on the software. It's a small fee to give you what's called FLIR Tools Plus. FLIR Tools Plus has an option where you can stitch photos together. So if I took 6 good photos with some continuity, left to right, up and down, I could take 6 photos of that aircraft if I was close enough and I couldn't capture it all in the same field of view, and I can put it through the stitching mechanism. I actually shot the, oh, what's the name of that big hotel in Las Vegas with the water show?
Bellagio.
Bellagio, thank you. Shot the Bellagio. I took about 18 shots of the Bellagio. I shot it from just about where the water show is. We stitched it. I'll tell you what, if I showed you the photo, you'd have no idea I stitched it. It's a wonderful photo. So the stitching is a great function, but if you're going to take a really detailed image and you want detailed temperature points inside of that entire image, T660, you're going to have to go with the 6 series camera.
Okay, one last question. What's the difference between a thermal imager and an infrared camera?
Nothing. Same thing. Thermal imager and infrared camera is the same. They're both harnessing IR technology. So really, we call it infrared, we call it thermal imaging, we call it IR, whatever you want. I mean, basically, it's the same thing.
Okay. The last question was to display our email again, and if you go to the next slide, Elliot, we have my contact information on there. Great. So that's it for questions today. And if you have further questions or would like to find out more about Transcat's products and service offerings, you can contact us at 800-800-5001 or on the web at transcat.com, or you can email me directly at nvanwert@transcat.com. Thank you for joining us today. Thank you for your time. We hope you got something out of the presentation and that you continue to join us for future Transcat e-learning webinars. Thank you, Elliot, and thanks to all for attending.
Thank you very much, Nicole.